Hello, Engineering 203. It's good to be back in lab, or kind of lab. I guess you're going to be doing some simulation, and I will try and show you what you'd end up when you built it. Most of our labs actually in this class were simulation. For instance, lab number 2 and lab numbers 4 and 5, we're going to do virtually exactly the same way that we would do even if we were meeting. So in that regard, it's very much the same. Now obviously this digital lab, lab 6, lab 7, you would have done, but you would have done in lab, but I'm going to do that for you and turn the simulation over to you, which I think has some value too. So with that, I'll give you kind of a little heads-up meeting like we would always have at the beginning of each lab, and turn you loose. If you go to the tab, go to the web page for Engineering 203, and at the bottom of the web page, it's a little bit hard to find. There's lab. There's a lot of sub-pages on there, but one of them just says lab. So you click on that, and you'll be able to go and find experiment 6. And I broke the experiments up into individual labs this term so that I can post them one at a time and make sure that they're applicable to what you're doing. I realize this is kind of small and maybe a bit out of focus, but you'll be able to download a copy of it, so you should be able to see it a lot better with that. But it gives you a min-term expression in step number 1, and wants you to draw the logic diagram for that, and then make a truth table. And you can use 3 input gates, 2 input gates, however you want to do it. That truth table will then look a little bit like this. Make sure I'm still in frame here. And I didn't want to spoil the surprise, so I just started. The truth table is actually quite a bit longer than this, but I worked down until I got to the first term. You'll obviously do the entire table, but I didn't want to spoil your fun and then give you something you can just copy onto your own work. So I've got the first term here, which appears right there, so that A and B and not C appears right there, and then obviously you'd get the 2 other terms as you went along with that. So that's the truth table for that. And then you're asked to redraw the circuit, but this time using only 2 input and OR gates. So we're going to be trying to use some of these common gates here. If you go again to the lab subpage, you'll find a PDF titled Gates, and I've put these here. You've got the 7400, the universal chip, the NAND chip, the 7404, that is the inverter. You've got the 7408, that's the AND, the 7410, that's 3 input, we won't be using that, and finally the 7432, which is the OR that we'll be using. So we'll be using these 2 input ORs, we'll be using the 2 input ANDs, and we will be using the inverter. And then I think next week on lab number 7, we'll be using the 7400. Okay, so those are for your use. So back to our lab, it says to redraw the circuit, but this time use only 2 input and OR gates. So let's see what that looks like. So again, you're going to have more to this. I just started this, but the first part of this would probably look something like that. You've got your 3 inputs, A, B, and C, and with 2 inputs you daisy chain these together like that. There's a set of ANDs. You're going to have 2 more sets of 2 ANDs as you go through this. So that's the kind of circuit, and then you're going to want to figure out how to build that. And this is I've actually built this thing here. If we look at the truth table, or not the truth table, but the min-term expression here, it looks like if all of the variables are high except one of them is low, if A is low or B is low or C is low, then you get an output. So let's try that. I've got over here, and this is a little bit hard to see, I've got it propped up here, and I have lab number 7 here, so don't pay too much attention to that. This is laboratory number 6, so right there, concentrate on that. That's laboratory number 6, and I've got my switch here for the A input, the B input, and the C input, and then I've got my LED output over here. And this table, or this designer actually has our output. It shows a low or a high, but we can really just concentrate on that LED right there. Maybe I need something a little better to point at that with. I'll get the old pencil out here. you can that LED right there is what we're going to watch. So if all of these are high and one of them goes low, their A goes low and we get a high on that. B goes low, get a high on that, and C goes low, we get a high on that. So that seems to work. And we check other combinations, all of them low and whatnot, and all of them high, we don't get an output. So that seems to operate the way we would like it to. The one thing in constructing this that unfortunately, and this is the thing that I would always tell people when we did labs face-to-face, is you want a really good circuit diagram. So to that end, you are asked then, in step number 4, detail the above circuit. Step number 3, so that it could be built. Include a wiring diagram and pin numbers. So what does that look like? Well, what I would do is I actually just took and cut and pasted those gates that I gave you, and then I started to hook them up on paper. And I tried to use different colors. I used red for my +5, and they're probably not going to show up very well on this video camera, but you can get a little bit of an inkling. So red for +5, green for the grounds, because each chip needs the VCC, that's +5, and the ground is would be a 0. That's usually in the lower left pin. The pin number 14, the upper right pin, that's the VCC or the VC, and the positive 5 volts since we're using TTL. And then again, I could start to hook these together, and I haven't done the entire thing. I've done about as much on this as I did on the circuit diagram. Again, I don't want you just to be able to capture this and good enough. I want you to put a little thought into finishing up. And likewise with this. I don't want you just to capture it. I want you to put a little more thought into finishing it up. So I've just done part of this, but you can see how I come into the inverters, and then I've got the AND gates hooked together, and then the output of the AND gate is up into the OR gates, and from the OR gates I'm going to go to the output. We don't necessarily have to worry about this LED and this resistor, because that's taken care of in our board here. So that's what we've got. Remember, anytime that you use something from someone else, make sure that you reference that, whether it's me or someone else. That's just a good habit to get into. So chips from the Engineering 203 lab materials, just to show someone that you didn't do it, you were using it from somewhere else. So that's what we're looking for there. So now that you've got that, and if you were to build this in the years past when we built this, I always gave students a piece of advice, that spend your time on this wiring diagram here, come up with a really good diagram so that as you build it you can highlight these or check them off or something like that, so that you make sure you get it built right, because we have a lot more wires on here than we've ever had any other circuit. And these are kind of fun circuits to build, but they can be kind of frustrating if you're off by one pin. And yours truly, even when I built this thing, I couldn't see as well as I wished I could, and I was one pin off on this thing, so I had to do a little troubleshooting. So the best troubleshooting is to very carefully build it the first time, so you don't have to worry about going around with a logic probe and trying to sort that out. I also tried to have a little bit, and again you're going to have a hard time seeing the colors, but I tried to have my grounds as green, my +5 as red, my logic up to the A is a kind of a orangish color here, and then into the ORs, so into the ANDs is orange, and into the ORs is yellow, and then I come over here with the output that across there, that black wire. So try and keep it nice and neat. The other thing that I did is I tried not to go over the top of the chips. Okay, so if I suspected that a chip was bad, I could easily pull that chip out and put a new one in there. You have to be careful to pull the chip straight out so that you don't bend the legs, the pins on them. But if I put the wires over the top, it's probably more convenient. But if I then have to pull the chip out, if the chip's been burnt up or abused or something, then I have a problem getting it out of there. You'll notice the way I've built this, I can easily take those out. And again, for our purpose today, we're not looking at this port here, we're just looking at this. This is lab number 6. So the last portion of your lab is probably the biggest part, the most fun, is step number 5. Download and or use a digital computer modeling tool of your choice. So if you do a Google search on digital logic gate modeling tools, there's a whole bunch out there. There's ones that if you're suffering from bandwidth and you don't want to, or computer space, you don't want to download something, you can actually just build the model on their site and run it. There's ones that you can download. So find something that works for you. I'm not going to prescribe a particular one. I went and played with a couple. They're pretty straightforward. I don't think you have been in much trouble doing this step. And you know, maybe you want to play with 2 or 3 of them to start to build a battery of tools that you can do. My guess is you'll probably have the best luck if you find something that will model it like this. So you're going to model it at the gate level like that, rather than necessarily at the chip level like this. The reason that I made you do this is if you're actually going to build it like we could if we weren't fighting a virus, you'd want this to build this. But probably for the modeling process, you're going to be better off modeling it like this. Model the AND gates, the OR gates, and the inverters, and so forth. So that's your task then. You're going to build that model, and how do you turn this in? We're not going to, I had planned to do a full formal report, but with things changing and whatnot, I'm going to change that up a little bit. So our requirements here, what you need to turn in, and again, I realize it's probably a little bit small and blurry, but you have this document. You can download it in PDF form, so you can read it in better detail there. But it says prepare an executive summary to describe what you did and what you found. The summary should start with your name, date, class, and experiment number. So title this experiment number 6, your name and date up at the very top. There's no cover page, there's no table of contents, you just got one page here. The text, the summary of the text should be no shorter than half a page and no longer than 1 page. So you know, you got to show what you did. If you're going to have you know, big font and lots of space, it better be a full page. If you're going to crowd things up a little bit, it could be closer to 1 page, but you need to cover the material. The single page summary should end with your signature at the bottom of the page. Attached to the summary, you may place up to 4 additional pages. Okay, so I'm going to try and make this really concise. As you go on and continue to study and go into engineering, there's always going to be constraints, and oftentimes they will be constraints that you can't go over this. You can't yet you have to be very concise in how you put this together. So I think this is going to help in terms of us passing this back and forth as an electronic document, but it's also a good habit to get into. So you can attach to this summary up to 4 additional pages that might have diagrams. You're probably going to have some diagrams, calculations. You may not have calculations. Circuit, let's see, circuits, modeling printouts. You probably want to put something, proof that you did number 5. Or tables, your truth table, logic diagram. Any item that is attached must be referenced in the text of the summary, so you don't want to just throw pages on there like, oh, this is too short, it's not long enough, so I'm going to tack another page on there. That's not what we're looking for. If you put a page on there, if you put a diagram on there, if you put a circuit on there, make sure that you reference it in your summary. Okay, everything that is attached needs to be referenced in the summary. The entire document must be neat, of professional quality, and in PDF form, because that's going to be how you're going to submit it to me in PDF form. Speaking of that, you may need to put your signature in a picture. So you just do your signature, take a picture of it, and then cut it in as a picture. Most people are pretty clever about that. I'm not going to give you too much advice on that, because you'll probably come up with something way better than I will have. Couple of final notes here for this particular lab. Make sure you include steps 2, 3, and 4, and your proof or printout of 5 in your attached images, or in your attached pages. So you want to make sure that you're putting these in the attached pages. I don't want you to say, yep, I did number 5, yep, downloaded that and had fun. I want you to give me some proof of that, okay, a screenshot or something like that. Let's see, the final thought, experiment number 7 is going to be similar, probably actually will be easier. It looks a little ugly here, but it's actually probably going to be easier because we're not going to model the whole thing. But if you spend time systemizing some of these, coming up with the gates, coming up with a system for this, that may well pay off as you look to experiment number 7. I've got some notes here. Let me make sure that I covered all of these. I think the first lab that you turn in, I'm going to go fairly easy with the grading. You'll turn it in a PDF, email it to me, and I'll just email you back and just give you 2 or 3 sentences on things that were good and things that you may want to improve on, and I'll give you a grade on that. That's probably the easiest way, rather than me trying to print things out and grade them and try and scan them back to you and things like that. Hopefully it'll be great, and I can just say it's great and you get full credit. If there's things that need improvement, I probably won't take a lot of points off on the first lab, because it's a learning thing. I will point those things out that need to be improved, and then you'll want to improve those for the second and the third lab submission, so that you get full points on that. I think this digital Lab 6 and 7 are digital. We'll then do the midterm in week number 3. The midterm, you want to be prepared for that, but I would say it's definitely the easiest exam in this class, so that's one that you want to do well on. You want to get high points on that, because the other ones, I don't want to say that they're really horrible or super hard, but let's just say that the digital one's going to be a lot easier, so make sure you get lots of points on that. The exams are not comprehensive in this class, so we'll do digital, and then we'll wave goodbye to that, and we won't see that again even on the final. So the other thing to think about is laboratory number 2 is going to be using LT Spice. In the past we've used P Spice, but LT Spice seems to be a little more common. Students seem to adapt to it and use it better, so you may want to start doing that. I've got the some of the web resources on the website, and it has a spot where you can download that, and again, that's LT Spice. So I'll give you 4 circuits, and you'll simulate those with LT Spice, and that was exactly the way we used to do it in the past too. So we just you'd build those circuits and simulate them. Actually, the most difficult part, it seemed like, from years gone by with that one, is finding out what the answer is, and doing it by hand so that you can compare it to your LT Spice simulation. So if you've got some extra time as the term is firing up, you may want to download LT Spice and start to play with that. But anyway, you've got this information. You've got a week. You'll want to get this lab turned into me by Thursday of the following week when you got it, so that you'll get this in the first week, and you'll want to turn this in the second week. I think that's it. If you have questions, shoot me an email. Take care, and I'll be getting back with you.